So I've been in and out of Jicamarca, I think 27 times. I think Koki counted this. It started in 1980. I was 24 years old, a graduate student in Cornell. And I guess Jicamarca was younger than me, 20 years old or something. But it had so much more experience. I had to learn so much here. That first meeting wasn't very easy because we traveled. I think it was Don and Wes Schwartz and Bela Fayer and myself. We stopped in Panama. And then we stopped in Lima, but I couldn't enter Lima because I didn't have the visa to enter. You know, I'm Turkish. It never occurred to anyone that this Turkish guy needs a visa to enter Peru. So I was next in this plane leaving Lima, and it luckily ended up in Guayaquil in Ecuador, when I tried again. This time we found out that Ecuadorians have no problem with Turks, so they let me in. So I spent a day in Guayaquil, got my visa, applied for a visa. It took several days. I eventually made it to here. So those early years were incredible learning years. And Cesar Lajos mentioned about these printers that were printing things very, very accurately, little dots. Those are, I think, Versatech were the types of printers. And Mario Yerkik's names was mentioned. I want to take all these various people from whom I learned my Jicamarca talents and the radar talents and so forth. Mario was one of them, just like Koki was acknowledging me, I have to acknowledge many, many different people. And Mario Yerkik was Don Farley's graduate student, just about to finish his PhD on the new thing. The new thing was then radar interferometry. This is two-element interferometry, and Don Farley and Mario Yerkik had measured the velocity of electrons in the zonal direction using this technique. In the vertical direction, in the line of sight direction, it's just a Doppler shift, even though that is hard to interpret in case of electrojet because of type 2, type 1 issue, which we haven't quite solved even to this day. Angle of arrival measurements using interferometry, it looked like it was going to be very easy to measure the east-west drift velocity of the electrons. It turns out that that wasn't so easy either. There was a puzzle there. It was pretty much well known that that velocity had to exceed the sound speed, but it was consistently less than sound speed. And we had to discover eventually why that was the case. And that story has something to do with me and Rob Pfaff. Rob and I also shared many, many things. He was my roommate. Rob referred to his experiences during Condor. And I did my PhD. I finished my PhD pretty much before Condor. And for Condor, I was the postdoc here, and Rob was here to make measurements of these large-scale waves that one night in Cornell, in what room was that, Rob? 112, correct? In 112, we discovered these large-scale waves by taking advantage of these Versatech plotters. We make long plots of the spectrograms, effectively, and amazingly, we found these large-scale waves. And these large-scale waves had wavelengths comparable to the density gradient scale, and everything we knew about these electrojet was wrong. The dispersion relation had to be worked out, and then this factor of 2 velocity difference worked out to be the explanation. So Mario and then Rob, those are the early days. Now, how did I end up being in this group? Well, I was a Cornell undergraduate, and I was interested in physics. I was going to study engineering physics, but then I'm from Turkey. I said, hey, let me study something more practical. It's hard to do physics. I'll go to Turkey. Let me learn about electrical engineering. So when I enrolled in electrical engineering, I still like physics. So who was teaching the most physics-like classes? Of course, this group. In particular, Mike Kelly was a tremendous teacher. He really inspired me. After having his junior year electromagnetics course, I wanted to see what he's teaching in his senior year. So I took this course on the upper atmosphere physics. It was a very inspiring class. And after that, that was it. You know, there was no more class that Mike was teaching, but he insisted that I take the next class, which was being given by Don Farley. Okay, so then this is how I got entrapped in this business. I'm so happy about it. But then how did I end up working with Don rather than Mike? And Rob is asking the same question. By the way, at this point I was a senior. Rob was a beginning graduate student, and we were sitting side by side in all these classes, Don's class and Mike's class and so forth. And I went to Turkey in the summer, then came back to graduate school thinking that I was going to be working with Mike. But when we came there, they said a coin was flipped. And the result of that, Rob ended up doing the rocket stuff, and I ended up doing the radar stuff. So that's how, more or less, I ended up in this business of coming to Jicamarca maybe 27 times over the last 32 years. Then it was Condor campaign. In Condor campaign 83, well, basically, Don Farley, as soon as my PhD thesis was finished, why don't you go to Jicamarca? There's going to be a rocket campaign soon. Maybe there's some help needed there. And that was January. I think I was flying New Year's Day. On the 31st night, I was flying. I came in. That was also the El Nino year, the famous El Nino year with lots of Waikos and whatnot. And then we met with Ron. And another person spending his winter vacation here was Cesar Gonzalez. Okay, so there are three Cesars important that originally came from Jicamarca. Those are all my colleagues, and I want to thank all of them. Cesar Lajos, who spoke before me, Cesar Gonzalez, and my colleague Cesar Valladares. We are colleagues. And anyway, Cesar Gonzalez and I were sort of inspired by Ron to generate the data acquisition software which was going to be used in Condor campaign. And he had some vision. He said, this has to be modular. And actually, there were some Jicamarca engineers, and there they are sitting, Miguel Leyva and Walter Camacho. They had just generated the sort of assembly language codes, the basic codes for this new Harris 800 computer. And over that month, Cesar Gonzalez and I sort of like built the next stage. We were just ready, just in time for the Condor campaign. Mike is not here, right? Anyway, so the story is that on that very first day of the Condor campaign, it was going to be a spread-F launch. And I don't know, 8:20 or whatever, usually when these plumes start, as plumes started showing up, it was on the RTI, we could see a plume. And Mike Kelly said, let's launch, Erhan, let's launch. Except that that particular software that we were going to use had never been tested. And so I couldn't say, hey, you know, I'm not sure. We have to test this. And he was furious. I said, but, you know, just give me some time. These days, those days, we used to record the data on 20-minute tapes, and we recorded that particular plume. And then we played it. It was all in good shape. And the next plume, sometimes these plumes come in sequence. 40 minutes later, the second plume came, and that was that. Anyway, so Condor campaign was a great campaign. We did electrojet stuff. We did spread-F stuff. And interferometry was being used with increasing creativity. By the way, interferometry is something that Ron Woodman, even before Mario Ierkic and Don Farley had used, it is a technique that he had used. He showed some of the data today, the 1-degree offset of the IGRF model from Jicamarca measurement. That was perhaps the earliest use of interferometry at Jicamarca. Anyway, so we were doing a lot of things. One of the things we did was measuring the aspect sensitivity of the E region echoes. And later on, Heisel did this with Farley for F region echoes. Those were interesting years. But those were also years where I started getting into the MST business. Why? Because I ended up going after Cornell, after this postdoc, I ended up going to University of Illinois, and my road there crossed Professor Bohill, another name that has come up earlier today. And I had no idea what MST radar technique was. Of course, it was another one of those things that was invented here, Woodman and Guillen paper that Cesar Lajos made reference to. And Sid Bohill said, hey, you don't need to know too much. You just integrate it. They are there every day. You're going to go and get these things. So anyway, so we ended up here interacting. Now, by this time, I had some graduate students. And Fahri Sürücü was one of the graduate students at that stage. And we did some interferometry with MST technique, with mesospheric echoes. The kind of imaging, the extra information that you get in the electrojet and F region didn't quite show up in the MST echoes, but we learned a lot. And another thing that we tried at those years was frequency domain interferometry. But this was also the time frame when I was really learning about radars because of Ron. Okay? So my teachers are Don, Ron, Woodman, and or did I miss Mike? Mike, the first inspiration. Don Farley, from whom all the techniques, the tricks of the trade was learned. But then implementing things, it was Ron Woodman at Jicamarca. Also, all the contributions of the engineers like Miguel Leyva and Walter Camacho and Otto Castillo. Bela Feyer, always an inspiration. And others, Gerardo Vera, whose name came up, he was the organizer for these experiments. We had countless nights making measurements of various things, including spread F, speculating whether or not the plumes are going to come, or are we going to have a dull night. One of those nights, Ron and I measured the explosive spread F, which is another interesting story that came up during the ISCA meeting. So that takes us more or less into the early 90s or so. Let me accelerate. Probably I ate up all my time, right? Yes. But few interesting things happened in the mid-90s. One was the Miseta campaign. There must be some old Miseta person here, or original Miseta. There you are. Yeah. Yeah, Meriwether, yeah. So in Miseta, we tried to do incoherent scatter together with coherent scatter. We want to see as much as the plumes as well as the drifts and even density. So we started using different methods. And I had a student at the time, Santanu Bhattacharya. And one of the nice things that happened is that when he applied the usual way of treating coherent echoes into incoherent scatter echoes, we got something very nice. We saw a very, very, very narrow spectrum coming from the incoherent scatter. And typically, yeah, of course, this is boring. Some of you maybe, but typically incoherent scatter signals were processed in a different way, pulse-to-pulse correlation from which you get the velocity. However, the serendipitous sort of thing that Santanu stumbled into gave us a very, very nice way of measuring drifts. In fact, then we could do spectral fitting, and this solved many problems. For many years, Ron was interested in doing velocity estimation, not only using pulse-to-pulse correlation, but correlation over many pulses. But that was a tricky business. How you combine them, how you weight them was a tricky sort of a thing because of correlated errors, it turns out, in the time domain. When you go to the spectral domain, all those correlated errors disappear, and you just do a fit, and you get very, very nice results. So already what was one of the best measurements at Jicamarca became even better after that accident, let's say. But another thing that we discovered at that point was these spectra were super narrow. Okay, because there is a spectral width, you think that maybe you can fit to the spectral width and get some temperature measure. When we tried that, the temperatures were super cold. I mean, the ionosphere was like 300 degrees rather than 1,000 degrees that we expect. And that led us to start suspecting something is going wrong. Maybe we are doing something wrong. But eventually, it turned out that this part of physics, incoherent scatter physics, PERT to be, was not quite correct formulated. And Sixto Gonzalez, not Cesar. This is Salzer and Gonzalez were the first ones to sort of like crack this puzzle. And the last 10 years, we have sort of followed their steps and really worked out the details of incoherent scatter PERT to be, which is a sort of a nice thing. And in this story, one of my great aides was Marco Milla, one of my graduate students who first an engineer here, then came to University of Illinois. I should acknowledge Julio Urbina, who was also another engineer and who worked with me. With him, we did some sporadic E-work, mostly in Arecibo sector. We had a portable radar that we took into various places to support various rocket experiments, and Julio worked in that project. I have another current student, Pablo, who is working also on incoherent scatter problem. Along the line, at Jicamarca, many, many discoveries were made. Imaging was started, and we saw beautiful imaging results yesterday from Dave Housel's talk. All that work started in the early 90s. And this super big meteor stuff, that was something that we stumbled into because of the increase in height resolution and time resolution and so forth, something that should have been there, but nobody was noticing these things. That was early 90s. My student, Elaine Chapin, and I sort of stumbled into this, and now it's big business. These types of long duration meteors became the in thing to study, and there is a lot of good physics, and Jicamarca was also instrumental there. And I guess it was Elaine's good friendship with Julio that eventually got Julio to Illinois. Anyway, many, many years, 32 years, many travels and many graduate students. It's been fun. Thank you.